In this video, we are going to look at Pydantic models, the single most important building block for handling structured data in FastAPI. By the end, you will know what a model is, how to declare one, and exactly what FastAPI does with it when a request arrives. Imagine your endpoint receives JSON with a product name, a price, and an optional discount. Without any framework help, you call request.json, pull out each key, check that the price is actually a number, that it is positive, that the name is not empty, and you write that code in every single endpoint. It is repetitive, error-prone, and the first thing that gets skipped when deadlines loom. Think about filling out a tax form. The form itself enforces structure. It has labeled boxes, expected formats, and required fields. You do not write new rules for each person who submits one. The form design does the work. A Pydantic model is that form for your API. Declare it once, and FastAPI uses it to accept or reject every incoming request automatically. Pydantic is a separate library. FastAPI depends on it heavily. You create a model by subclassing BaseModel and listing your fields with standard Python type hints. Pydantic reads those hints at class creation time and builds a validation schema from them. FastAPI then uses that schema in three directions: passing the incoming request body, validating its contents, and serializing your return value back to JSON. We import BaseModel from Pydantic and FastAPI from FastAPI. The product class declares four fields. Name must be a string, price must be a float, _stock defaults to true if the caller omits it, and description is an optional string that defaults to none. In the path operation decorated with @app.post, we declare the parameter product with the type hint product. That single hint tells FastAPI to read the request body as JSON and deserialize it into a product instance. If any required field is missing or the wrong type, FastAPI responds with a 422 before your function is ever called. The response_model equals product annotation tells FastAPI to serialize the return value using the same schema, filtering out any extra fields you did not declare. When a request arrives, FastAPI inspects the function signature and sees a parameter typed as a Pydantic model. It reads the raw request body as JSON, passes it to Pydantic, which tries to coerce each value to its declared type. A string digit like 9.99 becomes the float 9.99 automatically. If coercion is impossible or a required field is absent, Pydantic raises a validation error, and FastAPI converts that into a structured 422 response with field-level detail. This same schema is also published in the automatic OpenAPI documentation at /docs, so your API description always matches your actual code. Pydantic models shine whenever your endpoint deals with structured multi-field JSON data. They eliminate a whole category of manual validation code. However, they are not the right choice for every situation. A single query parameter like a page number does not need a model. File uploads use FastAPI's file and form utilities instead. And creating a model for every tiny internal data structure in your application can lead to over-engineering save models for the boundaries where external data enters or leaves your system. To recap, a Pydantic model is a class that inherits from BaseModel with type-annotated fields. You place it as a type hint on your endpoint parameter, and FastAPI handles passing and validation before your function runs. Failures produce automatic 422 errors with clear messages. And response_model gives you the same power on the way out, ensuring your responses are always well-shaped and consistent.